So guys, what we have been looking on this part of chapter 5 is energy of electrons. So if I'm going to compare energy of electrons in different shells, is it fair to say that electrons which are in larger distance from nucleus, they feel the attraction of nucleus by less amount? In other words, electrons which are on first shell, you're more attracted by nuclear charge than electrons which are on second shell. Why is that? Suppose you have gone to a beautiful lake in the summer. It's real hot. You're enjoying the sunshine, and you feel you're too hot. You move to a shade. Can I say you're feeling the heat of sun much less when you're sitting under the shade of a tree? By the same token, if electrons are on second shell, they don't feel as much attraction as electrons on first shell. So effective pull that they receive is total nuclear charge minus shielding effect. What is the shielding effect? If tree is shielding you from sunshine when you are sitting under the shade of a tree, by the same token, electrons on the first shell are shielding electrons on second shell from the attraction of nucleus. So the nuclear charge felt by an electron depends on shielding effect of inner electrons. So what they feel, we call that effective nuclear charge. The amount of the heat that you receive from sunshine when you are sitting under shade of a tree, we call that effective heat from sun. Why? Because part of it is shielded, of course, by tree. So this is the logic. Can I say electrons in the inner shell are directly pulled by all the charges of nucleus? But electrons in the outer shell, although they are pulled by nuclear charge, however, they are repelled by the electrons of the inner shell. So the total amount of attraction by nucleus is reduced because of repulsion by the negative charges of electrons. Negative and negative repel each other. Negative and negative repel each other. So this effect of repulsion, repulsive effect of inner shell electrons result to less attraction by nucleus. So we say effective nuclear charge is less than inner shell electrons. Because outer shell electrons are shielded by inner shell electrons. So now if I'm going to talk about energy of electrons, can I say there are two factors? Remember we said if n is equal to 1 and n equal to 2, electrons on second shell here are further apart from nucleus than inner shell electrons. Obviously, electrons in n equal 2 have more energy. That means they have more freedom than electrons on n equal to 1. Why? because these are under the strongest pull of nucleus. They don't have as much freedom. They don't have as much energy. So one factor which contributes to the energy of electrons is the main shell. Or do they belong to the first shell, second shell, or third shell? Electrons on third shell have more energy than electrons on second shell, which have more energy than electrons on first shell. That's one factor. The other factor, we can, again, this is coming from mathematical calculation of energy of electrons using wave functions. And we know that s orbital has minimum energy, p orbital has more energy, p electrons have more energy than s electrons, d orbital have more energy, d electrons have more energy than p electrons, f electrons have more energy than d electrons. So if I am going to calculate energy of an electron, I need to look at two factors. Number one, what is the shell number? Number two, what is the subshell number? Remember S, P, D, and F. These were called subshells, right? So we have to look at two factors. Combine these two factors, then we can calculate relative energy of electrons in an atom. Let me go to the next slide. I want to show you effect of shielding. So effective attraction of an electron toward nucleus, effective pull of an electron toward nucleus depends on total charge of the nucleus minus sigma, and this is shielding effect. Let me give you an example. If I ask you how many electrons in sodium, you can look up the periodic table and tell me 11. So out of these 11, you have 11 protons. You have 2 electrons on the first shell, 8 electrons here, 2 electrons here, and you're left with this 1 electron. So number of inner shell electrons which are shielding, can I say 2 plus 8? So 10 electrons are shielding this 1 electron from total charge of 11 by the nucleus. So what is Z? Charge of nucleus. What is charge of nucleus? Well, charge of nucleus is number of protons. So can I say number Z is 11? And how many inner electrons? 10. So effective Z, effective charge of the nucleus, that this 1 electron is filling is 11 minus 10 is filling charge of 1 proton. And if I measure the radius of sodium atom, the radius is 186 picometer. If I go to magnesium, atomic number is 12. There are 12 protons. So let me change here 12 protons, 2 electrons, 8 electrons, and 2 electrons, right? So what is the charge of nucleus? 12. How many inner electrons are shielding these 2 electrons? 8 plus 2, 10. So what is the effective nuclear charge for electrons on the third shell? 12 minus 10 is 2. So can I say these electrons are even, you're pulled strongly, much more strongly than sodium? Do you see how atom of magnesium is smaller than atom of sodium? Why? If outer shell electrons are being pulled by more effective charge, they come closer to the nucleus, atom is getting smaller. By the same token, if I look at aluminum, which has got 13 electrons, and this time, in case of Al, I can say 13 protons here. 2 of them on first shell, 8 of them on second shell, then you have got 3 electrons in the outer shell. So can I say effective nuclear charge is all the charges minus the 10 electrons which are inner shell, 3 effective charge is charge of 3 protons. So these electrons in magnesium are being pulled much more strongly. These 3 electrons in aluminum, I meant. These 3 electrons in aluminum are pulled much more strongly than outer shell electrons of magnesium. So do you see the atom is still smaller because electrons are pulled much more strongly. The outer electrons are pulled much more strongly by the nuclear charge. And if I go to silicon, atomic number 14, there is 10 inner electrons. The effective nuclear charge is increased from charge of 3 protons to 4 protons, and you see the atom is getting even smaller. So this was simply telling you about the fact that effective nuclear charge is different from total charge of the nucleus. And we see this effect by going to the periodic table. As effective Z increases, radius of the atom decreases, atom becomes smaller. And that's what you see. See, as I go from, on the third row, as I move from sodium to magnesium to silicon, the atoms are getting smaller. And this continues as I move in a period from left to right, atoms are getting smaller. And in fact, in a column, as you move down a column, atoms are getting larger. All right, let's go back to energy of electrons. If I look at the energy of electrons, remember, this was suggesting that the higher the main shell number, the less energy. And then we had a second factor. So the higher the main shell, the more the energy of electrons. And then when we look at the subshell, we said F electrons have more energy than D, which have more energy than P, which have more energy than S. So if I combine these 2 factors, then I can come up with relative energy of electrons in an atom. And, well, we know minimum energy electrons are in 1s. And if I consider only the main shell, S and P are in the same shell, shell number 2. But the fact is, P has more energy, so I have S and P on second shell, but P have more energy. On the third shell, although all of these belong to third shell, however, we know that P orbital have more energy than S. So I'm going to put this a little bit higher, and 3D has even more energy. And the same thing about fourth shell. Look, if you compare the energy of 4s, this is 4s energy. Let me get rid of the other ones. And 3D has a slightly more energy than 4s. Although, this is 3D. Although 3D belongs to third shell, however, because of its orbital, because D subshell have got more energy than S, so 3D has more energy than 4s. So if this is the actual relative energy of multi-electron atom, in hydrogen we don't have that problem, because there is only one electron, there is no repulsion between electrons, there is no shielding effect. But in multi-electron atom, the relative energy of orbitals changes. So do you see 3D? Although it belongs to the third shell, it has more energy than 4s. And we give you a chart that you can predict relative energy. You don't have to memorize this. The chart is on the exam table. Let me come back and do the video for the rest of the material. This is a good point, I think, to stop.